Under measures of dispersion, today we'll discuss about standard deviation. Okay, standard deviation, in short abbreviated as SD. In fact, if you think of the definition of standard deviation, then you can abbreviate it as RMSD. Okay, RMSD, where R stands for square root or simply root. Okay, M stands for mean, S stands for squares, and D stands for deviation. Okay, I'll elaborate on this. So, what is standard deviation? It is the square root of the mean of the squares of the deviations of the values that are given from the mean of the distribution. Okay, so this is the definition of standard deviation. What is it? It is the square root of the mean of, mean means what? Average. Okay, it is the square root of the mean of the squares of the deviations of the values from the respective mean, from the mean of the distribution. Let us see what it means. Okay, you have a set of values given to you, right? Suppose I label the variable as x. The values are x1, x2, x3, dot 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 dot, it goes on up to xn. Okay, now what does this definition say? It is square root of something. Forget it, we start from the innermost term. What is it square root of? First of all, we have to take the deviations of the values from the mean. What is the mean of the deviation distribution? Generally, mean is given by summation x by n, isn't it? This is the mean of the distribution. So I have to consider the deviations of each of these values from the mean. That means I have to consider x1 minus x bar. How much x1 deviates from the mean? x2 minus x bar, x3 minus x bar, and so on till xn minus x bar. This gives me the deviations of the values from the mean of the distribution. What do we have to consider? Next, squares of these deviations is what is coming under definition. That means this x minus x bar that we have calculated, we need to, this is deviation. We can label it as d also, or simply di. Di stands for this suffix over here. Individually, if I consider, then it is di. This is your d1, this is your d2, this is your d3, and so on. Or simply d. Okay, it doesn't matter. So we have to consider squares of the deviations of the values from the respective means. In other words, we have to consider di square, that is whatever we got here, square of that, x2 minus x bar square, x3 minus x bar square, dot 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 dot, up to xn minus x bar square. This gives me the squares of the deviations of the values from the mean. Now, according to this definition, what do I have now? I have to find out the square root of the mean of these squares of deviations that I have obtained. That means I have to find out, first of all, the mean of the squares of the deviations. That means I have to find out the mean or average of this that I have obtained and take the square root of that. Okay, so what is the average of the values that I have obtained here? Average means what? Sum of the values by total number of values. So it will be the average of squares of the deviations from the mean. So it's average of di square, actually average of this, or simply d square, and therefore it is x1 minus x bar whole square, that is this value, plus the next one, x2 minus x bar whole square, plus x3 minus x bar whole square. This way it goes on till xn minus x bar whole square, is this value, divided by, what is the total number of values that have? 1 to n. divided by sum, that is n, number of observations, that is n. So in short, we can write this symbolically also, isn't it? This summation, symbolically, how can we write it? We can write it as summation of, this is summation, addition, summation of, I'm keeping the suffixes I because this is changing, xi, this is fixed, minus x bar whole square by n, where I ranges from 1 to n. This is how we write it in summation notation. And so what do we have to consider next? So what did we obtain? We have obtained this is giving me the mean of the squares of the deviations from the mean, isn't it? This is the average of, or the mean of the squares of the mean of, or the average of the squares of the deviations, mean this, which symbolically, in short, we can write it in compact form like this. And we have to consider, according to the definition, square root of this. So square root of the mean of the squares of the deviations, in fact you can write this as root over of summation di square by n, where I ranges from 1 to n, just to make it look compact and neat. Okay, and di square is this, we have already seen. This gives me the standard deviation of a distribution by virtue of the definition of standard deviation. Or you can say this is the definition of standard deviation, from which we get this formula for deriving the standard deviation of a distribution. So standard deviation is basically square root of the mean of the squares of the deviations from the mean. That means it is square root of summation of xi minus x bar whole square by n. This follows from definition. Now here notice something, the values that I took of x, no frequencies were associated. If frequencies are associated, I hope you remember how to find the average. In general, x bar is what? In general, x bar is summation xi by n. But the moment frequencies are coming in, that means we do summation fx or summation fi xi, where I ranges from 1 to n. It's understood, even if you don't write, it's okay. By n, sorry, not this n now, it is summation of fi, which can be denoted by capital N. Okay, so this is what replaces x bar formula in terms of formula. Basically it's the same, but we write it symbolically like this. Okay, so therefore when I'm taking average of di squares, if frequencies are associated, in that case what will we do? So if frequencies are associated, then here I will have f1 into x1 minus x bar whole. That means each of these will get multiplied by the corresponding frequencies. That means you will have a frequency column in the given. Besides the value of x, you will have another frequency column over there. This is suppose f1, f2, f3 dot 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 up to fn. Fn is over here. So each of these will get multiplied with the corresponding frequencies, so that the average will be summation f of this, summation fi di square it will become. So this is what we will have, f2, f3, finally it will be fn into xn minus x bar whole square. So in that case what will happen? In that case here you will have a fi associated with di square. Instead of writing small n, you will write capital N. In other words, it is summation fi over here. Okay, so that is the only difference, because of the mean. When frequencies are, because of this average that we are considering of the squares of the deviations. Okay, if frequencies are associated, then these squares of the deviations whose average we are taking have to be multiplied with the corresponding frequencies and to be divided by, instead of this n over here, you can write capital N or simply summation fi. It's the same thing. So let us summarize this now. Let us write it neatly, because it's becoming very congested over here. It's looking untidy. So let us write it very neatly now. So SD is basically equal to root over of summation xi minus x bar whole square by n. I'm not writing I ranging from 1 to n. Okay, it's understood. if frequencies are not there, and if frequencies are there, it is summation fi xi minus x bar whole square by summation fi. This is coming from the definition of standard deviation as square root of the mean of squares of deviations. In fact, in short, you can also write it as root over of summation di square by n with root over of summation fi di square by summation fi, just to make it look compact. Meaning is the same. Di stands for deviation of the values from the mean. That means each of these di's where di is equal to xi minus x bar. Accordingly, d1 is x1 minus x bar, d2 is x2 minus x bar, and so on. Now we have alternative formulae also. We have something called working formulae for standard deviation. And what is that working formula? Let us write it. SD is equal to root over of summation xi square by n minus x bar whole square. Okay. If frequencies are not associated, now this is by definition. I think I'll write this side. This is by definition, and this is your working formula. That means this formula can be used for calculation anywhere and everywhere, whereas this formula should be used only when x bar is integer. Otherwise you will get, because if x bar is not an integer, then you are likely to round it off, okay, if it is fractional, and when you round off, there are chances of an error coming in, which is called rounding of error. So therefore, to avoid that, it's better not to use it when x bar is not an integer. When x bar is an integer, you can proceed with it. Otherwise, it's better to use the working formula. Then you don't have to worry about anything else. If frequencies are associated, then the formula is summation fi xi. How we are getting this, I'll come to that, by summation fi minus x bar whole square. What is the difference between the two x bars over here? Here, x bar is simply sum of the values by total number of values. But here, since x bar frequencies are associated, so it's summation fi xi by summation fi. That's the only difference. Okay. So this is what we have for working formula of standard deviation. In fact, you can write a shortcut formula in terms of d also. This is said to be, do we have space? Yes, this is said to be shortcut formula, that is SD. In fact, SD, there's a symbol also, sigma. Okay, this sigma, it looks like a 6, but the top head is horizontal. This is small sigma, this summation symbol is your capital sigma, and this sigma over here is your small sigma, Greek letter. So, there is an alternative formula also, that is sigma is equal to root over of summation di square by n minus d bar whole square if frequencies are not associated, and you have root over of summation fi di square by n, by summation fi minus d bar whole square. What is the difference? As usual, here d bar is simply sum of the d's by total number of values, and here d bar is frequencies are associated, so it's summation fi by di by summation fi. That is the difference. And what is di? Di is not now xi minus x bar. I have used di over here as xi minus x bar. Just a notation for the sake of convenience to make it look good. But here di is where di is xi minus a. That is your assumed mean. Okay, so this is basically assumed mean method that we can use over here. Notice, appearance wise it's the same, isn't it? Shortcut of the working formula, appearance wise it's the same, but Significance is different. Here just the values are taken directly. Here the values are decreased, isn't it? Decreased by a certain value and then substituted over here. Besides this, we have an important formula. So how many did we get? This was formula number 1. Okay, the first one. This is the working formula number 2. Shortcut can be used as number 3. Now we have the fourth formula over here. What is formula number 4? The fourth one is your step deviation method. We had step deviation method when we did mean, isn't it? So here also we have step deviation method. As the name suggests, when will we use it? In fact, the formula, let me write first. Formula is sigma is equal to, or SD is equal to H into root over of, I hope you can see, yes, summation Fi ui square by summation Fi minus u bar whole square. That is summation Fu by summation Fi actually whole square. In fact, you can write it as sigma is equal to H into, as I have been using, summation Fi ui square by summation Fi minus u bar whole square, where u bar is summation Fu by summation F. Okay, so this is to be used either way. What is u? Where ui is xi minus a by h. H stands for length of the class intervals and a stands for assumed mean of the distribution. And notice, since I have length of class intervals involved, so this method is to be used only when class intervals are given. In other words, when you have a grouped distribution. Otherwise, you cannot use this formula for any other distribution. If it is ungrouped, you cannot use this formula. Okay, so these are the formulae that you have to memorize and keep in mind. There is no other option. Now, one thing you must remember, that is sigma or standard deviation is square root of something, isn't it, by virtue of definition. So you have a term called variance. Variance is nothing but the square of the standard deviation. Please remember this. Or rather, when SD is this, SD is what? By definition, root over of summation xi minus x bar whole square by n. I'm considering the basic definition, okay, where frequencies are not involved. So the moment you do SD square, it becomes summation xi minus x bar whole square by n. And this SD square has a special name. It is termed as variance of the distribution. Okay, so square of the standard deviation has a special name. It is called variance of the distribution. Instead of asking you standard deviation, they can ask you to find variance. The meaning is the same. Formula is the same. Only thing is you have to consider whole square part. That is, without the root, you have to consider the value that you get. That will be your variance. Not only that, I had discussed about coefficient of variation to compare two distributions. Yes, that is for comparing two or more distributions. What did I say? We generally find out the coefficient of variation, isn't it? Coefficient of variation, which is also written in short as CV, is equal to sigma by x bar into 100. How we apply this, we will see when we do the numericals. But this is a very important measure, so that if you notice, CV is actually directly proportional to the standard deviation. That means if the percentage, this is basically what? SD is a percentage of the mean, isn't it? Standard deviation is expressed as percentage of mean. I have mentioned all this earlier. Okay, so when the CV percentage is more, it means sigma is more. That means it's directly proportional. The spread is more, variation is more. That means the more the spread, less the consistency, isn't it? And whereas when CV is more, the less is the mean. So mean of the distribution less means CV will be more. So this is how they are related to each other. Directly proportional and inversely proportional to the mean of the distribution. So let us apply all these to a few numericals, okay, for grouped as well as for ungrouped distributions. Grouped, ungrouped, we can do discrete as well as we can do frequency distributions as well. So let us apply that. The first example, find the variance of the following distribution. Okay, values are x and frequency is also given. That is, for 2 it is 4, for 4 it is 4, for 6 it is 5, for 8 it is 15, for 10 it is 8, for 12 it is 5, for 14 it is 4, and for 16 it is 5. This is what is given. You have been asked to find the variation. Let's apply the definition. First we will see whether we can apply the definition, because remember I said when you apply the definition you have to make sure that x bar is an integer. Okay, otherwise we will apply the working formula. So let us check what is x bar. Yes, so first we will draw the x columns. X and F we will draw first, and then according to the formula that we are using we will do the rest of the table. So it's 2, 4, 6, 8. I hope you can see. Yes, you can see. 2, 4, 6, 8, 10, 12, 14, 16. Frequencies are 4, 4, 5, 15, 8, 5, 4, 5. Okay, we need to calculate x bar. So below we are calculating x bar. I'll draw a line over here. X bar is equal to summation fx by summation f. This is the, what is summation f? Add up and see. This is 4 plus 4, 8 plus 5 plus 15. You have your you are allowed to use your calculators, so I don't think I have to show you the addition. This will, I think, come to 50. Okay, this is your summation f. And fx you have to do, so the next column is f into x, and fx is how much? This is 2 into 4, 8, 4 into 4, 16, 6 5s are 30, 8 into 15 is your 120, 10 into 8 is your 80, 12 5s are 60, 14 4s are 56, 16 5s are 80. So summation fx is how much? Let us calculate. 8 and 6 and 6. 6 and 6 is your 12 in the units place. And there's an 8 over here. So it will be 0 and 8, 5, 5, 10, 16, 15, and 5. And it's a 4. I hope it's correct. I think it is correct. Okay. So this gives me 450 by 50. Is it an integer? Of course it is. It is 9. So this is an integer. So I will mention that I'm going to use the definition that using sigma is equal to root over summation of frequencies are there. So it's fi into xi minus x bar whole square by summation fi. This is what we are going to use. Okay. Accordingly, let us draw the columns. What are the columns needed now? So this part is over. The line is crooked. Okay. So we need xi minus x bar. So let's write that. X minus x bar, that is x minus 9. This is the column. Yes, we need square of that. So it's x minus 9 whole square. And we need f into this. So it's f into x minus 9 whole square. Okay, so these are the remaining columns that are needed. Anything else? No. Summation of this we will get from the last column. So what do we have? This is x minus 9. Mind you, this is your x. Be very careful. There are chances of making careless mistake. So it's 2 minus 9. That gives you how much? Minus 7. 4 minus 9. That gives you minus 5. 6 minus 9. So it's minus 3. 8 minus 9. Minus 1. 10 minus 9 is your 1. 12 minus 9 is your 3. 14 minus 9 is your 5. 16 minus 9 is your 7. X minus 9 whole square means square of this. This is what we will do. So this is 49. This is 25. 3 square is your 9. 1 square is 1. This is 1. This is 9. This is 25. This is 49. F into this now. That means we will multiply. Be very careful. If required, mark it or keep your fingers on the two positions. Otherwise, there are chances of going wrong. That is, we are going to multiply this with this. That means 4 has to be multiplied with 49. I think the first one I will write 4 into 49 and the second one also 4 into 25. Okay, like that we will go on. So it's 4 into 49. That gives you how much? 196. 4 into 25 is your 100. Then comes 5 into 9. That makes 45. Then comes 15 into 1. That makes, I hope you can see, yes, 15. Then comes 8 into 1. That is your 8. Then it comes 5 into 9. That is 45. 4 into 25 again, so it's 100 again, and 5 into 49, that makes 245. So this is what we did now. Summation fi into xi minus x bar whole square is what is needed over here. So we will do the calculation of this total. So how much is it coming to? Let us check. This addition will come to, I think, if I'm not wrong, 754. Addition I don't have to teach you. You are big girls now. Big girls can do addition very easily. So now let us substitute. So this is going to give you root over of 754 divided by summation f is how much? 50. 754 divided by 50. How much is it coming to? It will come to, I think, root over 15.08. Okay, they have asked you to find variance. Variance means what? Sigma square. Okay, so you will write your conclusion that therefore variance is equal to sigma square, and that is equal to 15.08. This is your answer. And if they had asked you standard deviation, then what would you do? You would have to calculate square root of 15.08. No problem, isn't it? So it's perfectly okay. So this is how we calculate standard deviation. Let's do another one, or other variance, whatever you say. Let's do another one. That is, I'll draw a table then. Find the standard deviation of the following distribution. Find the SD of the following distribution. This is the next question. Values of x are 18, 19, 20, 21, 22, continue till 24 till 27, 25, 26, 27. Okay. and the frequencies are 3, 7, 11, 14, 18, 17, 13, 8, 5, 4. You've been asked to find the standard deviation of this distribution, where the frequencies are 3, 7, 11, 14, 18, 17, 13, 8, 5 and 4. So, which formula will be used? We have already used the definition once, so I don't want to use the definition again. Let's use something else. Let's use the working formula. Okay. Now, working formula, there are two of them. One is shortcut sigma. The class intervals are not there, so we will not use the last step deviation method. One formula is sigma is equal to root over summation fi xi square by summation fi minus, I'm replacing x bar, summation fi xi by summation fi whole square. This is one formula, working formula that we are talking about. And the other one is root over of in summation fi di square by summation fi minus summation fi di by summation fi whole square. These are the working formulae that I have, where the first one uses the values of x directly and the second one over here, di is xi minus a. A is the assumed mean. So which formula will I use? Now notice something here, the values of x are quite big. Whole square you have to do, and you have to multiply with these also. So it's better to reduce those values and make them small. So I'll reduce those values and I will use this formula. Okay, that is assumed mean method I will use. So table I'm drawing. X is 18, 19, 20, I hope you can see, yes, 21, 22, 23, 24, 25, 26, till how much? 27. Assumed mean generally we take towards the center, so I think I will take, what shall I take, 23? More or less it's at the center, mark it, 23, box it, and write this is equal to A. This is your assumed mean. Okay, so I need to reduce these values now. So let me reduce first, then I will write the F column because I'm going to use this formula. Di is xi minus A, that is xi minus how much? 23. This is what I want to do in the next column. Then I will copy the F and I will do the rest. So what are the values? Here it's 18 minus 23, isn't it? 18 minus 23 is minus 5. 19 minus 23 is minus 4. 20 minus 23 is your minus 2. 21 minus 23 is minus 2. This minus 1, 0, 1, 2, 3, 4. So this is your di. Okay. What else do I need? I need fi di and I need di square also. So let me do di square over here. This is 25, this is 16, this becomes 9, 4, 1, 0, 1, 4, 9, 16. This is your di square. Now let us do fi di and fi di square. For that I need to write down what are the fi's. So I need to write down the frequencies. I'm drawing a double line over here. This is optional. There's no hard and fast rule that you have to draw it. Okay. So what are the frequencies? Let me write down. Frequencies are 3 over here, 7, 11, 14, 18, 17, where is it? 13. Lost track. Wait. This is for 3, this is 7, this is 11, this is a little higher, 11, this is 14, this one is 18, this is your 17, this is your 13, this is 8, this is 5, and here I have 4. So these are the frequencies. So let us do fi di as the next column, and or fd, whatever, and fd square. These two are going to be the remaining columns. We need summation f, so here you can do summation f is how much? Summation f or summation fi is the same thing. How much is it? I think it will come to 15, 15, 10, okay, this will come to, I think, 100. Okay. F into D, be very careful. You are going to multiply this and this now. Okay, so minus 5 into 3 is your minus 15. Minus 4 and 7, that is your minus 28. Minus 3 and 11, minus 33. Minus 2 and 14 is your minus 28. Minus 1, it's better you mark, otherwise you keep your fingers and do, otherwise there are chances of taking the wrong value. Minus 1 into 18, that is minus 18. 0 into 17 is your 0. 1 into 13 is your 13. 2 into 8 is your 16. 3 into 5 is your 15. 4 into 4 is your 16. So this is your FD. I need summation FD, so I will write summation FD is equal to addition now. Anything cancelling? Yes, 15 is cancelling over here. Okay. What else? Nothing else is cancelled. Okay. 16 twos are 32, no? So this is 32 over here and there's a minus 33 over there. And this minus 18 and 13 will give you, okay. So it will come to FD, 33, 28, 16. So we come to, wait, I run this in right, minus of 62 if I'm not wrong. Okay. Then I need FD square, so that we fill up the column. Okay. FD square now means multiplication of this with this. 25 into 3, like that, okay. 25 into 3 is your 75. 16 into minus 20, I hope I'm, no, sorry, 60, see, I'm only making a mistake. 16 into 7 is this and this now. 16 into 7 is your 112. I hope you can see, yes. Then comes 9 and minus 30, no, see, again I'm making a mistake. 9 and 11. Okay. 11 and 9, that makes 99. Okay. Then the next value, 14 with 4 now. 14 4s are 56. Then 18 with 1, that makes 18. 17 with 0 is your 17. 13 with 1 is your 13. 8 with 4, 32. 5 with 9, 45. 4 with 16, 64. So summation FD square is out. Sum of this column, you can easily do the calculation. Summation of FD square, how much will it come to? Something around, I think, addition you can do yourself. Check and see whether it's coming to this value or not. 514. So we are using the formula FIDI square. Okay. So you will write below this. You will continue using this formula. Using sigma is equal to root over of summation FIDI square by summation FI minus summation FIDI by summation FIDI square. What do I get? Let me put the values. That is, therefore, enough space? Yes, you can see. Sigma is equal to root over. How much is summation FD square? 514. So it's 514 divided by 100 minus summation FD. How much did I get? Minus 62 by 100 whole square. This is what I have. So calculation part, what will you do? 500, it's easy, you have divided by 100. So you can easily write the values as root over of 59 minus of 0.62 whole square. So it's coming to, how much will it come to? I'll write the final answer because this is something you can do easily. 2.1807 is giving the final answer. You can leave it as approximately 2.2. Okay, so this is the SD of this distribution. What have we used? We have used the shortcut method. Okay. Next we'll do group distribution. How to calculate the SD for group distribution.